Alright, so this question is asking us to do two things. First, draw the locus of points that are equidistant from the two given points. And you can see that in each question they're giving us 2 points. And then the second part says to write the equation of the locus that is drawn. So there's 2 tricky words here. First is locus. So that means a position. Sort of similar to the word location. So it's basically what is the position or location of all of the points that are equidistant, which means equally distant from the 2 given points. So let's just see what that looks like. If we drew out a graph here, let's say we have point A right there, and that is at position 1, 0. We'll say we've got point B right here, and that's at 3, 0. Then one particular point, which we'll call it C, that would be equally distant from those 2 things, would be at point 2, 0. But they're asking for the locus of all of the points that are equally distant from those 2 given points. So let's just imagine, what would that look like? It would look like a line that runs straight up and down. And you can see that at any stage, point here, point D, for example, it would be equally distant from A and B. So it kind of makes a little isosceles triangle. Or if we drew another point up here and called it point E, it's a little bit off, that point would also be equally distant from A and from B. So any point along this line right here would be equally distant from point A and point B, and so that line right here would be the locus of points equidistant from the 2 given points. So let's go ahead and start working on this with question 27, where our 2 points are 3, 0 and 9, 0. Alright, so our first question asks for the points 3, 0 and 9, 0. So we'll start with 3, 0 right there. And our other point is at 9, 0. And this one is very similar to what we just solved. It's just going to be a straight vertical line that's running exactly in the middle of these 2 things, just like that. So it's going to be at the point, 6, 0, and then a vertical line. So what is the equation then? The first question asks us to draw this on graph paper. So that's step 1. And step 2 asks for an equation. So what's the equation for a vertical line? So the equation for a vertical line is just simply, normally when we write equations, they're in the y equals mx plus b form. But in this one, it doesn't really, this is a special case. We're not going to use y. Every point on this line right here, which is going to infinity, is at 6, is at x equals 6. So our equation is just x equals 6. And so that's our answer to the first question, which asks us to find the locus of points that are equidistant from point 3, 0 and point 9, 0. And it's just a vertical line that runs through the point 6, 0. And the equation for that is x equals 6. Alright, so the first point we want to plot is question 29, and that's point 9, 3. So we'll come over here to 9 on the x-axis and 3 on the y-axis and plot our point. It looks like we're going to run out of space for the next one, which is 15, comma 3. So we'll just pretend that there's a 15 out here. Make that a 15. And so just like we saw in the previous problem, the locus of points equidistant from these 2 points is going to be a vertical line that splits the difference between the 2 points. So one of them is at 9, the other is at 15. So there's 6 away from each other. That would mean that the point in the middle would be 3 away from each. So we'll just go 3 spaces from the 9 to here to 12. And we'll just draw another vertical line, just like that, with an arrow because it goes on forever. And that, again, is what the locus of points, the locus of points equidistant from these 2 points looks like. And again, the equation for that kind of thing is going to be x equals 12, because on that line, the x value is always going to be 12. And we'll go ahead and finish up with the last one. So we've got point -2, -4. And then we have point -2, +8. Should be right here. And so what's the point that's equally distant from both of those? Well, we're moving 4 spaces to get up to the x-axis, and then another 8. So that's a total of 12. So equally distant between them would be 6. So we can jump down 6 from 8 down to 2. And that point -2, 2 would be equally distant. And the locus of all points equally distant from those 2 points would be a horizontal line that splits the difference between the 2. And the equation, we lost our equation over here. We remember that this vertical line was x equals 12, because at any point over here, x is always going to be 12. You could have 12,6, 12,7, 12,8. So the equation for the vertical line was x equals 12, and the equation for the horizontal line is going to be y equals 2, because all along this horizontal line, y is equal, the y value is 2. We get -3, 2, -7, 2. So for question 31, the locus of points equidistant from -2, -4 and -2, 8 is a line that looks like this, and the equation is y equals 2.